Hello Gators, this is 1-7 Writing Proofs Day 3. Before we start taking a look at proofs, let's remind ourselves about the different vocabulary for pairs of angles. I'd like you to stop the screencast and decide what the pair is called. What's its name? Some of them have more than one name. And here are the answers. Let's take a look at our theorems. We have added 2 more theorems to the top of the list. We worked on the bottom 4 on day 2. Now we're working with 2 more. The first one is called the linear pairs theorem. It says that the sum of the measures of a linear pair is 180 degrees. Let's take a look at how we go through the steps of the proof. The first step is ADB. Notice that it's a straight angle. So straight angles are equal to 180 degrees. So that would be definition of straight angle. Just like the definition of a right angle is 90 degrees. Now we have little angle plus little angle equals big angle, and that's called the angle addition postulate. And I want you to notice that we have this angle here, and we have the same angle here. So that means these 2 quantities must be equal to each other, and that's called substitution. You could also call that the transitive property if you wanted. Substitution. Oops. Substitution. All right, let's take a look at the next theorem, and the next theorem is called the vertical angle theorem. It says if you have vertical angles, they are congruent, and that's what we want to prove. So step 1, definition of a vertical angle. Remember, vertical angles are formed by a cross, and they're across from each other. Now we have a linear pair. We're going to use the last theorem, and let me go back up to show you what the last theorem was. Linear pairs theorem. The sum of the measures of a linear pair is 180. So we're going to say sum of the measures of a linear pair is 180. Now we know they both equal 180, so they must be equal to each other. That's called substitution. And I'm going to subtract angle 3 from both sides. Subtract angle 3, subtract angle 3. That's called subtraction property. Subtraction property of equality. And once I get the equals, I want to get to congruent statement. So to go from equal to congruent, it's definition of congruent angles. And so now anytime I see vertical angles, I can say they have the same measure. Let's go ahead and practice this. I notice that I have vertical angles, so I'm going to set them equal to each other because I know they are congruent. I'm going to add 8 to both sides. And now I'm going to divide both sides by 12, and the answer is 4. Let's take a look at these. These are not vertical angles. These are a linear pair, and we just talked about the theorem. Angles in a linear pair have to add up to 180. This will be 18x is equal to 180, and x is equal to 10. Let's take a look at this problem. I want you to notice that we have some vertical angles. I'm going to make the arrow here. Okay, so that is my arrow. So that means this whole angle here will be equal to this angle right here. So make sure you understand where the vertical angles are. So 8x will be equal to 140. And then x will be equal to 8 goes into 140. 1 time 8, 6, 0, 756 with 4 left over. So that's 17 1/2. Let's take a look at this one. I can see these are vertical angles right here. So to get x, I'm going to do x minus 15 equals 52. I'm going to add 15 to both sides, and that'll be 67. To get the y, I'm going to write 4y is equal to 128. I'm going to divide both sides by 4, and that'll be 32. Okay, and as a summary, we have these 6 theorems. Again, we discussed 4 of them previously, and we discussed 2 of them today. That's the end of the screencast.